done, so we would have had maximum melting in the summertime. Okay, and according to that, we should actually be somewhere near a precessional temperature minimum. We should be actually in the cool part of the cycle because we have less melting in the northern hemisphere in the summertime. Okay, so very good. Now some of you might have questions about ice ages, but hold on, because I have some questions for you. So remember I said it was a theory, but it's just a theory, and there's still a lot of things we don't understand about ice ages. But for starters, one of the most convincing pieces of evidence for the astronomical theory of ice ages is this. It's called the Vostok power spectrum. Does anybody know what a Fourier transform is? Yeah? Okay, so do you want to explain what a Fourier transform is? Yes. Okay, so this is the series that we wanted to do a Fourier transform on. Okay, so if you take any signal here, and if the signal is somewhat periodic, the Fourier transform will decompose this signal into the wave functions that comprise it. So we'll decompose it into frequencies and amplitudes of waves that make up this signal. So if this signal here was the sum of a bunch of wave functions, maybe 100,000 year cycle, right? And then maybe there's something else added in there. Then if we took the Fourier transform, it'll show us that there's a 100,000 year cycle, and there's another cycle, and so on. Okay, so just believe it. So this is the Fourier transform of that data series that I just showed you. And this is frequency on the bottom axis, and this is amplitude. Okay, so here is the 100,000 year cycle of eccentricity. It shows up very strongly, and that's what we expect, right? Because it's about 100,000 years between the interglacials in the ice ages. And then here's the 40,000 year cycle of obliquity. That was in there as well, somewhere in the mix. And here's the 25,000 year cycle of precession. Okay. One of the biggest mysteries of the ice ages is when Milankovitch first produced the orbital theory, he thought that precession was the dominant cycle of the ice ages because it affects northern hemisphere solar radiation by about 12%, whereas eccentricity was only thought to be a minor contributor with about 0.2% change in solar radiation. So, the big question is, why does eccentricity look like it's the dominant cycle in the ice ages? Because Milankovitch had it completely backwards, right? If he was right, precession should have been the big one, and then obliquity, and then eccentricity. But it's the other way around. So, any ideas? Okay, so it's a big question. One of the scientists that made the book, where I got this out of, he says that maybe this 100,000 year cycle is not necessarily due to orbital eccentricity. It could be due to another orbital element, orbital inclination. So all the planets lie roughly in the plane of the solar system, but they're also inclined a little bit. And they always want to be accelerated towards where there's more mass. They always want to be accelerated towards Jupiter's orbital plane because it holds most of the angular momentum of the solar system, okay? So they kind of bob up and down with respect to the plane of the solar system. And the Earth happens to undergo this oscillation about once every 100,000 years. Which is kind of funny because it's very close to this cycle. And Richard Muller from Berkeley is the guy who proposed this. And he says, I think it's orbital inclination that causes ice ages. And then another group of scientists who's led by Dr. Rial, he says, no, I think it's eccentricity, you guys are loopy heads. And they're yelling at each other, and I don't know. I think maybe they both might be right because these cycles both have the same frequency and roughly the same phase. So who's to say it's not actually two parts of the same cycle? Anyways, moving on. Another big question that a lot of people have is, why did the last ice age end abruptly about 12,000 years ago? This Younger Dryas event, this major warming event, about 5 degrees Celsius increase in temperature over about a few decades. It's more than 10 times the present rate of warming in the last 150 years. Very significant. Okay, but why does it happen so abruptly? Because these changes in the Earth's orbit are gradual, right? So why did it happen so abruptly? Well, some people say it could be related to positive feedback and albedo. So remember what albedo is? Reflective index of a surface. So when you melt ice and turn it into ocean water, you lower the albedo, so it absorbs more energy, and when it absorbs more energy, it can distribute heat to the areas around it and melt more ice, okay? And then lower the albedo again. Okay, so positive feedback, everybody understand that? And one of my favorite authors explains it very nicely. He says that the rivers in the local area freeze over in the wintertime, and when they melt again in the spring, it occurs very rapidly. So when it starts to melt, the ice will crack and it lets off a very loud sound like a gunshot, and within minutes the entire river is flowing again. So it's kind of like a catastrophic return to unglaciated conditions. So if you apply that on the larger scale, maybe the ice starts to melt and the ocean currents can flow again in that area and distribute heat to other parts of the planet and melt more ice. Okay, so is that a good explanation? Also want to point out that this time right here, the Younger Dryas, is right around the time of the last precessional temperature maximum when the northern hemisphere is pointed directly towards the sun at perihelion. Okay, so that might be a factor involved in the Younger Dryas. And the older Dryas, about 15,000 years ago, is very close to the obliquity maximum when the Earth's axis is tilted about 24.5 degrees. Very interesting. Okay, next, another big question. Back to this one. So why does the frequency of the ice ages change from time to time? Why did it seem like 2.5 million years ago the 4,000 year cycle switched on, and 1 million years ago the 100,000 year cycle suddenly switched on? It doesn't make any sense, right? Because the other planets in the solar system have been affecting the shape of the Earth's orbit for millions of years since the beginning of the solar system. So why is it that we only notice the 100,000 year cycle of eccentricity in the last million years? Any ideas? Sure, that's a good it's a good idea. My teacher said it might have something to do with thresholds. So just picture this. Before 2.5 million years ago, there weren't any year-round glaciations in the northern hemisphere. So some snow would fall in the wintertime, but it would all melt away in the summertime and you start again fresh next year. Then about 2.5 million years ago, you started to get the first year-round glaciations. So you would accumulate enough snow in the wintertime so that it wouldn't melt away in summertime, and you wouldn't start fresh new next season. Okay? So you start to get year-round glaciations, and this can affect the mass distribution and heat distribution of the planet. Okay? Possible explanation? Alright. Other than that, it's a real big mystery. They don't know what actually caused these very abrupt transitions in frequency, although I did hear somebody say it could be related to these geomagnetic reversals, rapid changes in the Earth's magnetic field where the North Pole becomes the South Pole very rapidly. Maybe that could have something to do with it, but we'll just leave it at that. Okay, and the 50-cent question. Will the Ice Age return? A lot of people ask this because it does look like we are in a pattern here, and where does the pattern lead? Well, most scientists say that the Ice Age may return one day